Hello students, myself Dr. Divya, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. In this session, we will discuss the problems on temporary hardness in terms of calcium carbonate equivalence using EDTA method. So before going to the problems, we'll understand what is the hardness and how it is defined. So determine. So hardness, one of the method is complexometric method, complexometric titration method that is used. So EDTA is a complex. EDTA is ethylene, diamine, tetraacetic acid. So this will form a complex with the metal ions that are present in water that are causing hardness to the water. So if you see this color, pink color before titration is just because of indicator that is forming complex with the metal ions. And after titration with the EDTA, it forms colorless compound or the complex, but the color is blue here just because of the indicator that is free in nature. So the indicator is used here is Eriochrome black tea. Eriochrome black tea. That is nothing but EBT. EBT is used as indicator. For example, if at all 1 ml of EDTA is equal to 50 ml of standard hard water, it means we are taking hard water that is intentionally made hard and standard, that is considered as a standard hard water. So this is just because like we have to standardize our EDTA. So for that 1 ml if consumed, so V1 is the volume of EDTA that complexes with 50 ml of standard hard water. So since 1 ml of standard hard water contains 1 mg of calcium carbonate, so that is prepared by dissolving 1 mg of calcium carbonate. So V1 ml of EDTA is equal to 50 mg of calcium carbonate. 50 ml will consume 50 mg of calcium carbonate. So that is how we take 1 ml of EDTA is equal to 50 by V1 mg of calcium carbonate equivalence in hardness. Okay, so if we take now unknown hard water, so 50 ml if we take unknown hard water, what do we have to do? This is the volume, that is the titer value, EDTA, titer value is the V2. So V2 into 50 by V1. Why? 1 ml is 50 by V1. So 50 by V1 mg of calcium carbonate equivalence. So if we take it or give it in the report in 1000 ml or 1 liter, it is like 1000 ml of unknown hard water sample. It is like we have to multiply with 1000 and that gives the calcium carbonate equivalence for 1000 ml or 1 liter. So that we express in mg per liter or ppm. mg per liter or ppm. So this is how we will be standardizing the EDTA and we get the total hardness. So in stepwise, if you see, a known volume of water sample is taken in a beaker or conical flask or beaker. So this is the water and in the burette we have EDTA. Okay, so next, boiled for half an hour. For example, if we take it in a beaker, it is boiled for half an hour. So after half an hour we are cooling it and filtrating. So this filtrate is titrated against EDTA again. So if you see here, this is boiled. So once we boil, what happens? The temporary hardness is removed in the form of carbon dioxide. So carbonates and bicarbonates are removed and only permanent hardness that we get from the boiled water. So that is done by adding EBT indicator and maintaining the pH at 10. Okay, if molarity of EDTA is M3 and titer value is V2 ml of volume of EDTA, hard water volume is equal to V3 ml and then the temporary hardness will be M2 V2 is equal to M3 V3 and M3 will be cross multiply M2 V2 by V3. That is how we get the concentration of hardness causing salts from this titration. So M3 is equal to M2 V2 by V3. Okay, so permanent hardness is again expressed in ppm by multiplying with 100, that is for calcium carbonate molecular weight 100. So we get in equivalence of calcium carbonate. Okay, so then we report in ppm. For reporting in ppm, we multiply with 1000. Okay, so total hardness is equal to temporary plus permanent that are causing hardness. So from this we get the temporary is equal to total minus permanent. Total minus permanent. This is how we determine the total hardness, temporary hardness and permanent hardness from a simple titration method. Next, going to the problems. 50 ml of boiled water when titrated against EDTA consumed 9 ml of solution. So 50 ml is consuming 9 ml EDTA. Okay, find out temporary hardness and express it in ppm of calcium carbonate equivalence if the hardness is 600 mg. So total hardness is 600 mg per liter, and molarity of EDTA is M molarity of EDTA is 0.001 molar. So we have molarity, volume. So we need to calculate the molarity of other. So the total hardness is 600 mg per liter. If we take M1V1 is equal to M2V2 for the boiled water is equal to M2V2 for the EDTA, we need to know what is the concentration in the water, so that we take unknown water. So 0.01 is the molarity of EDTA and 50 ml is the volume of water we take and 9 is the volume that is consumed. So we get 0.0055 molar. So this is the concentration. For expressing in liters, we convert into gram per liter by multiplying with molecular weight of calcium carbonate equivalence. So to express in calcium carbonate equivalent, we multiply with 100, that is the molecular weight of calcium carbonate, and the permanent hardness will be like after multiplying with 1000 we get in mg per liter, because it is liter, that is why 1000 ml is multiplied. So 550 mg per liter. So temporary hardness will be total minus temporary. So total is already given. How much is it? 600. 600 minus 550, that is nothing but 50 mg per liter. So this is how we calculate the temporary hardness from knowing from the total hardness. After we know the total hardness, we have to calculate the permanent hardness and then subtract both of them and we get temporary hardness for that water sample. Next one, calculate carbonate hardness of water. If 20 ml of standard hard water, so standard hard water SHW, which containing 1.5 gram of calcium carbonate per liter, which it requires 25 ml of EDTA for the end point, and 100 ml of water sample required 18 ml of EDTA, while the same amount of water after boiling required 12 ml. So after boiling it requires only 12 ml. Why? Because all the temporary hardness is removed. So they have already given the permanent hardness. We only need to calculate the total hardness and then go for the temporary hardness calculation. So 1000 ml of water contains 1.5 grams of calcium carbonate to make standard hard water. So we are making standard hard water. So 1000 ml contains 1.5 grams. So 1 ml contains 1.5 milligrams. So this is already given. 25 ml EDTA consumes 20 ml of that is also consumed for 20 ml of standard hard water. So that is again for converting into calcium carbonate equivalent, we have to multiply with this calcium carbonate equivalent. So 20 into 1.5 mg of calcium carbonate. So 1 ml of EDTA is equal to 30 by 25 mg of calcium carbonate. So here 100 ml of hard water consumed 18 ml of EDTA. So why 18 ml of EDTA? Here 100 we have taken, already given in the question. 18 ml of EDTA is consumed. Then 1 ml, how much is it? 18 by 100 into 30 by 25 mg of calcium carbonates, because 1 ml of EDTA is equal to 30 by 25. So 18 by 100 into 30 by 25 mg of calcium carbonate. So 1 liter multiply with 1000 and we get 216 mg per liter, that is the total hardness. For temporary hardness, we already know the permanent hardness. So total hardness minus permanent hardness, that is giving rise to 72 mg per liter or ppm parts per million. So this is how we will be calculating the temporary hardness when permanent hardness is already given, and we go for the calculation of total hardness and then go for the calculation of temporary hardness. Next is 0.5 grams of calcium carbonate was dissolved in HCl and the solution made up to 500 ml with distilled water. 50 ml of solution required 48 ml of EDTA for titration. So this is like making, if you see this sentence, 0.5 grams calcium carbonate, we are first dissolving in HCl and making up to 500 ml. That is nothing but standard hard water that we are making. Okay, so 50 ml of solution required 48 ml of EDTA. 50 ml hard water requires how much? 15 ml of EDTA. And after boiling and filtering, only 10 ml. Why after boiling it is low? Because temporary hardness is removed. So now we have to calculate the temporary hardness that is removed after boiling, and the total hardness is given as 312.5 ppm. So in the question they have already given 500 ml of standard hard water is having 0.5 grams, which is also written as 500 mg. So that is the total hardness is also given 312.5 ppm. So 1 ml of standard hard water, how much will it contain? 1 mg. When 500 ml is containing 500 mg, 1 ml will contain 1 mg. So for now, another line is this. 48 ml of EDTA is consumed for 50 ml of standard hard water. So that is again giving rise to 50 mg of calcium carbonate equivalents. When 1 ml is 1 mg, 50 ml is 50 mg calcium carbonate equivalents. So that is how we convert into calcium carbonate equivalents initially, so that it is easier for the next steps. Okay, so 1 ml EDTA is equal to 50 by 48. So 50 by how much is this? 48. 50 by 48 mg calcium carbonate equivalents. Permanent hardness. So 50 ml of boiled water is equal to 10 ml EDTA solution. It is consuming 10 ml EDTA solution. So 50 by 48 is for 1 ml. So 10 into 1 ml of EDTA is giving rise to 10.417 mg calcium carbonate equivalents. So if it is for 1000 ml, if you want to give, multiply with 1000 and we get 208.3 mg of calcium carbonate equivalents. That is nothing but the permanent hardness that we get in the mg per liter or ppm. So now we have to calculate the temporary hardness. So temporary hardness is equal to total minus permanent. Total is how much here? 312.5 minus 208.3. That is nothing but giving rise to 104.2 mg per liter or ppm. Next one, 200 ml of hard water require 30 ml of 0.02 molar EDTA with ammonium chloride, ammonium hydroxide buffer. That is nothing but we are maintaining at pH 10 and EBT indicator. Another 20 ml of water is boiled. So what are we doing here? We are boiling another 200 ml of water. That means we are removing temporary hardness. Okay, half an hour it is boiled and filtered, and the volume of filtrate is made up to 200 ml. Why we are making up 200 ml? Because the initial volume is 200 ml. By adding distilled water. Okay, 20 ml of this boiled water requires only 5 ml of 0.01 molar EDTA. Following the same procedure, calculate the temporary hardness and permanent hardness. So already given that M1 V1 is equal to M2 V2. So in that, if this is water and EDTA, we have to know the concentration of water. So M1 is equal to M2 V2 by V1. That is nothing but 0.02 into 30 ml divided by 200 ml is the water that we have taken, and that is giving rise to 0.003 molar. And strength we convert into by multiplying with the calcium carbonate equivalent, that is 0.3 gram per liter, and if you want to express in milligram per liter, convert multiply with 1000, that is 1000 ml, that is nothing but 1 liter. So 0.3 into 1000 giving rise to 300 mg per liter. So the total hardness is 300 mg per liter. So now we are doing the other one, permanent hardness. So for permanent hardness, boiled water is taken. Boiled water, M1 is equal to M2 V2 by V1. So what is the EDTA molarity here? 0.01. 0.01 into 5 ml is consumed EDTA by 20 ml is taken for the titration. So 20 is taken here and the concentration is 0.0025 molar. So converting into strength again, multiply with 100, we get 0.25 gram per liter, and the permanent hardness is 0.25 into 1000 is equal to 250 milligram per liter. So this is the total and permanent hardness. So the temporary hardness is like calculated from this total minus permanent, giving rise to 50 milligram per liter or ppm. So this is how we will be calculating the total and temporary and permanent hardnesses. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.